Hey guys, and welcome to another YouTube video on fractions. Now, if you'll recall, what we've been learning a lot about recently are fractions with like and unlike denominators, and we've been using whole numbers a lot in fraction form to kind of understand, especially with subtraction, with regrouping and borrowing, how we have to borrow from a whole number and rewrite a fraction as a whole number. This is going to help us. This is our prior knowledge, and we're going to use our prior knowledge of whole numbers to help us in understanding how to multiply mixed numbers with fractions. So we've done a lot of adding and subtracting. Let's take a look at what it means to multiply with fractions. So for example, let's say that we have 5 and 3/4 plus 2 and 1/3. Now, if we use our prior knowledge of fractions, we understand that any time that we have a numerator and a denominator which are the same, that equals one whole. And how we are going to rename these, I'm just going to draw a little line in the middle here. It depends entirely on our denominator. So with 5 and 3/4, we are dealing with fourths. Now, unlike, I'm going to make this a multiply sign. Sorry. Let's erase that so that this is clear. We are multiplying these now. Completely different thing. And we can't multiply these the way that they are. And usually, when we're dealing with adding and subtracting, which we've done all year, we have to change our denominators first. But here we're going to do things a little bit differently. If you will recall, one way that we use to change these is multiplying our denominator times our whole number and then adding the top number. So if we were to use that strategy, we would multiply 4 times 5 and get 20, plus 3 more would be 23, and we keep our denominator as 4. Here, 3 times 2 is 6, plus 1 is 7, and like always when we're looking with these fractions, we're going to keep our denominator the way that it is. So here we have 23/4 times 7/3. 23 over 4 times 7 over 3. That's going to, we can even use our knowledge of place value to help us solve this a little bit easier. And here's how we can do that. Let's go ahead and erase these guys since we have that written out already. 20 plus 3. Okay. 23 times 7. We know that 0 times any number is 0. 7 times 2 is 14. We're going to bring down our 0. Power of 10. 7 times 3 is 21. So here we have partial products. 141. Our 140 plus 21 is going to be 161 over 12. Now remember that one thing we need to know about fractions is that we have to interpret them as division problems. So this line here is our division line, right here. So another way to read this problem instead of 161/12 is 161 divided by 12. And then you can ask yourself, how many times will 12 go into 16? Because we know it won't go into 1. It will go into 16 one time. 1 times 12 is 12. We find a difference. Remember, difference means subtract a 4. We bring down that 1. And that is going to, how many times will 12 go into 41? 12 times 3 is 36. 12 times 4 is 48. And that is too big to go into 41. So 12 will go into 41 3 times, and the difference between 41 and 36, 7th and 8th and 9th, 40, 41, is 5, and then we bring our 12 down here. Now, that is one way to do it. Another way to do this problem, if we're looking back, okay, let's undo a bunch of these things here. Let's find another way to look at this problem. This is what we originally talked about in this lesson, and that is how to use our prior knowledge of whole numbers to give us a better understanding of how we can rewrite this problem. Okay, so if I know that up here, I can make this box even more. If I know that up here I'm dealing with fourths, and I have 5 whole numbers. These are my wholes and these are my fractions. How would I write 5 wholes in terms of fourths? Well, there's one whole plus another whole plus another whole. Now we have 3 and 4 and 5. Okay. That's going to be, if we're adding fractions as normal, we're going to keep our denominator because we have fourths. 4 times 1, 2, 3, 4, 5 is going to be 20/4, plus the 3/4 that we have would be 23 over 4. And the same for our 2 1/3. Now we would have 2 is going to be the same as 1 plus 1. And each one of those is a whole, which would be the same as 3 of our thirds. So 3/3 plus 3/3 would be 6/3, plus our 1/3 would be 7/3. Now remember, we're multiplying these, and all we have to do when we multiply is find the product of the top and bottom, and we have our answer. And just as we did in our previous problem, when we find your answer, you simply divide. Now that was a lot of work, and it was really complicated to look at. So let's look at a different example. Let's do a smaller one. Let's do 1 1/2 times 2 3/4. Okay? We can use the old method, which is, let's give ourselves lots of space when we do this. Multiply and then add. And that's going to give us something, and we know that our denominator is 2, we're going to keep 2. 2 times 1 is 2, plus 1 is 3 over 2. And here we have 2 3/4. 4 times 2 is 8, plus 3 more is 11/4. So now we have 3 over 2 times 11 over 4. We know that the answer to this problem is going to be multiply the top and the bottom. 3 times 11 is 33 over 8. And whenever we have a problem like this, there's two ways. On your end of grade test, you might actually have an answer choice that allows you to keep it as an improper fraction, but more than likely you're going to have to change. So remember, we use this line to represent division. So if we read this as 33 divided by 8, we know that's our next step to find a mixed number. 33 divided by 8. Oops. Right. So 8 cannot go into 3. Obviously, if we look at that, there's 3. Can we fit 8 into that? No, we cannot. So we have to use our multiplication facts. I know that 8 times 4 is 32. We have to find the difference, and that is 1. And because we are now trying to make this a proper fraction, we already had an improper fraction in our previous example. We had 33/8, and we're trying to change it to a proper fraction. So whenever we have a proper fraction, we know that we must have a denominator on top. These are the numbers that we have to work with, 8 and 1. Denominator must be smaller than the numerator. Okay? There is one other thing that we need to look at when we're talking about fractions, and it relates back to when we learned earlier this year how to simplify fractions, and that's called cross-canceling. So let's say that we have a problem like this. We have 4/5 times, I don't know, 10 over 9. Okay? This is a little bit different because what we're going to look at when we talk about cross-canceling, we're talking about drawing an X. So I like to draw an X in the middle to be like my multiply sign. And that means that this 5 is connected to this 10 and this 4 is connected to this 9. So I ask myself, can I make this even smaller? So 5 can go into itself one time, and 5 can go into 10 two times. So now we have 4 times 2, that is 8, and 1 times 9, which is 9. So we could get the same answer if we did 4 times 10, which would be 40, and 5 times 9, which would be 45. We could reduce that to 8/9. But when we're talking about fractions, we always want to deal with them in the easiest way possible. So this is another thing that we're going to talk about in the coming weeks. So let's just, as a quick review, let's remind ourselves that fractions are division problems. Okay, so as an example, 2 over 3 is actually equal to, you will get an answer with a mixed number as 2 divided by 3. Actually, let's do a different one. Let's do 3 over 2, because really when we talk about dividing to find a mixed number, we start with an improper fraction. So here we have 3 gets divided by, 3 is divided by the 2. 2 goes into 3 one time. We subtract and we get 1.5. I hope that this was helpful for you. And as always, leave a comment if you have a question, and I will be happy to answer it on YouTube. Have a good day, and I will see you next class.